The question is, the particle travels along the path. So this path has been given to us, and you at an instant time t equal to 0, this is at the origin, x y z equals to 0, so it is at the origin. So you have to find out the distance of this particle and the magnitude of the acceleration at time t equals to 1 second. This is a snapshot taken at that time, and if velocity in the x direction is given, so let me write down this data. Velocity in the x direction is 5 feet per second, where time is in seconds. So you have to find out the two things. One is the position vector, I would say position vector or magnitude of the position. Let me write down the formula. This is the x part and this is the y position of this component. So the other thing is the acceleration, and you have to do the same magnitude of the acceleration for the two components, ax square. These are the two formulae which you have to use in order to answer this question. So I would start from here. So let's start from here. Y equals to 0.5 x square, and if you take the time derivative for this path, you will get the velocity 0.5 and 2x times x dot, because we have to do the chain rule. Since this is not the time dependent variable, so we have to do the x dot again. So so over here so let's do one more thing. So this is x times x dot. So what is my x square? So let's do one more thing from here, from Vx. So Vx, it is equal to 5 times t. So we know that Vx at time t equals to 5 at time t equals to 1 second. So at time t equals to 1 second is 5. So we know this is 5. We know x dot is equal to 5, but we do not know what is x position. But we can find it out. If we go from velocity, you integrate it, you get the position. So let's do this integration. So can I write down like dx is equal to v dt, vx dt, from 0 to x position, from initial velocity, which is 0 to 5, I would say 1 second, because this is time dependent. So if we do the math here, 5t square over 2, and you can take the time variable as such, then you can apply it later on. So let me find the expression here. Find the expression. So x equals to 2.5 t square. This is the expression for the x position from the origin. This is the at time t equals to 1 second. That's my objective, because it says you have to take the time t equals to 1 second. So what is the position? 2.5 feet. So now we have gotten this answer, 2.5 feet. So now you see we have found both variables for plugging it into y component of the velocity. Initially we did not know about x position, but we had some other information provided in our solution, which is vx. So we found x from there. So what is vy if you plug in 2.5 times 5? Can you help your professor? What do you guys get for vy? 12.5? 12.5. Okay. Now let's do this one more thing here. So can I write down like ay from, so ay is the time derivative of x times x dot. So before I go to the time derivative of this, let's do the let's finalize this answer for probably r x square plus y square. What is my y square now? So let me show you. This y has been found, since x has been found from here. So can I find out y, which is 0.5? which is 0.5 times x square. Do you get that position? So now if you found this position, so you can find out the complete answer. X is 2.5 feet square, 3.125 square, and if you solve for this, you get 4 feet. So position of this particle after 1 second, it is 4 feet. It has covered 4 feet distance. Have you understood this first part? Now the next part is you have to solve for this this formula. Let's plug in everything in this formula to find out the second part. It is asking you find the magnitude of the acceleration. We have found the particle distance, which is 4 feet. The magnitude of the acceleration we have to find. So let's see, ax, you have to take the time derivative of vx, which is equal to what? 5 times t. You agree with me? So 5 times t, it is equal to 5. So in order to find out ay, look over here, you have to apply the product rule of differentiation. First function into the derivative of second function, second function into the derivative of first function. And now what is x? We already found this is, look, 2.5 feet. Can I write down 2.5 feet here? And what is ax? It is equal to 5 feet. What is x dot? We already know this is 5 over in at 1 second. So 5 square. And if you solve for this, you should get 37.5 feet per second square. And that's it. We have almost finished this question. So ax, it is equal to 5 square. Ay, it is equal to 37.5 square. And if you solve for this, you should be able to get 37.83. This is your answer.